Hi, Algebra 1. Our first lesson for this distance learning together is on systems of equations. So first of all, a system of equations is just when you have two equations at the same time. So what we looked at in our linear unit was graphing one line at a time. Then we had our parallel and perpendicular unit, and we graphed two lines at a time. That's very similar to this lesson that we're going to be doing today, except that the lines don't have to be parallel or perpendicular. It's just any two lines on a coordinate plane together. When we're looking for a solution to a system of equations, that would be what makes both equations true. So the point where the two lines meet or intersect or overlap is what would make both equations true, and that will be our solution. Now we have seen parallel lines that don't touch, so there are systems that have no solution. And we've also talked about if two lines have the same slope and the same y-intercept, then they're the same line and they would have tons of solutions because they touch or overlap in tons of different places. So first of all, I'm going to sketch a graph of what each of these different types of solutions might look like. So we've got our little coordinate plane here. Exactly one solution would be when two lines meet in one point. So let's say that's our first line. Notice I'm putting arrows on my lines. And then we have another line that does something like this. So this point right here, where those two lines meet or intersect or overlap, would be the one solution for that system. Then we would have an infinite. Infinite means never ending, an infinite number of solutions. So that would be when we have these two lines that are actually the same line, and so they would end up being graphed on top of one another, and they touch everywhere, so they would have an infinite number of solutions. And finally, no solution, and this is the one where we would have those parallel lines that never intersect. So if they don't touch, then they don't have a solution. All right, so the first way we're going to solve our systems is by graphing. We are also going to use some technology to help us graph. We used the app or the website Desmos when we were investigating whether or not lines were parallel or perpendicular. And we're going to use that same app to help us graph these lines. It'll be more efficient use of our time. So first of all, go to the website Desmos. And I'm going to type in those two equations that we had. Our first equation was y equals 3x plus 5. And our second equation was y equals negative x minus 3. So we can see our two lines graphed here. We can see that they meet in one point. With Desmos, what you can do, I'll be clicking because I'm on a computer, but on your iPad, you can just tap the line and you'll see these gray points that come up. And those give you some points on the line that you can use to graph it on our coordinate plane in our notes. So this point, negative 1.67, is not the easiest point to graph. So I'm just going to grab these points 0, 5, and negative 2, 1. And notice that that was our red line, so that's that 3x plus 5 line. And I'll graph it in red here too. So we had 0, 5, and negative 2, negative 1. And then we're going to connect those points with my beautifully straight line, as they always are for those of you that have had me before. All right, now we're going to take a look at the other line. So tapping our blue line, we can see that we have negative 3, 0, negative 2, negative 1. Notice that point was also on the red line. That's our solution. And 0, negative 3. So negative 3, 0, negative 2, negative 1, and 0, negative 3. So we have one solution, and the one solution to our system is negative 2, negative 1. All right, here's our next system. So we're going to go to Desmos. I already have these typed in to save us a little bit of time. Please feel free to pause the video so you can type these in and practice with me as well. So right now I have my red line turned on. So that's our first equation, the 2y equals negative 3x minus 6. So we can grab a couple of points on this one to graph it. And it looks like we have the point negative 2, 0, and 0, negative 3. Now let's go ahead and turn on the blue line and see what happens. Notice the blue line covered up the red line. We have these same points on the blue line, negative 2, 0, and 0, negative 3. So these lines are on top of one another, which means they touch each other in lots of places. And so this would be one where we have an infinite number of solutions. So again, we had the points negative 2, 0, and 0, negative 3. So those are the points that I'm using to get a quick sketch of my line. If you don't remember the word infinite, that's okay. You can just also say that there are many solutions. All right, circling back to this, as a reminder, there is one more type of solution, and that is this one right here. We didn't see that one in one of our examples, but there could be a potential where there is no solution when the lines are parallel and do not touch at all.